Okay, recognizing endothermic and exothermic reactions. These first two right here, you already have the answers to these. They're in the vocabulary crossword puzzle that you did on the previous page. So go back and look at those. Let's start with number 3 though. Okay, where am I going to find this? Well, back here in Canvas, let's look at Canvas real quick. And you're going to, let's go to our Canvas page. Okay, so right here it says Law of Conservation of Energy and Heat Transfer Notes. Click on that and it's going to bring this up right here. Okay, so there's Law of Conservation of Energy again stated. And what's heat of reaction? You're going to see that later. The answer to number 12 is going to be down in here too. We'll talk about that in a moment. It's right here in this conservation of the energy section, the answer to number 12. But let's go down here. Okay, notice how we have endo and exothermic reactions. You can see what that looks like in a graph, but also we have these comparisons here that we're going to use to answer these questions. Okay, let's look at number 3. In an endothermic reaction, heat will be a reactant or product. Circle your answer. And the delta H will be positive or negative. Well, if we look right here, we can see if we go down, it talks about this, okay? It says delta H is negative in an exothermic reaction, and it says delta H is positive in an endothermic reaction, okay? And is it a reactant or a product? Okay, well, right here, it says heat is on the product side in an exothermic reaction. You see that? I'll highlight it. Heat is a product. And then in an endothermic reaction, heat is a reactant. Okay, and then we'll look at some reactions for that. So in an endothermic reaction, let's go back to our worksheet here. Ooh, there's weird lighting on that. Okay. So right here, number 3, in an endothermic reaction, heat is going to be on the reactant side. Why? Because heat is going into the system. Okay, so we're going to have heat going into the system. So that's on the reactant side. Okay, and delta H will be positive. All right, and we're going to skip number 4. We'll look at that here in a minute. In an exothermic reaction, heat is going to be on the product side. Why? Because product is exiting the reaction, or heat is exiting the reaction. So it's a product, and delta H will be negative. Why? Because we're losing heat. Okay, and then is that going to feel hot or cold? Okay, well, let's go back here again to this. All right, so if heat is coming out of the system, okay, what do the surroundings feel like? Okay, so let's look right here, the surroundings. If I'm an exothermic reaction, right here, you see I'm going to highlight it. In an exothermic reaction, I'm losing heat to the surroundings, so what happens? It gets hotter. If it's endothermic, you're gaining heat. So the surroundings are losing heat, so it feels colder. I know that seems weird. All right, let's go back to here. All right, so in an endothermic reaction, it's going to feel colder. The surroundings will feel colder, but in an exothermic, it's going to feel hot because heat is being released from the reaction. Let's look at some actual reactions, though. 7 through 11. All right, so if we're looking at these, it's showing us energy, and let's recall that energy is measured in joules or kilojoules. So that's what we're going to see, energy. Right here it just says energy, but just say we had 220 kilojoules of energy, because you're going to see these on the next page over here where it actually has the energy listed there. Okay, but on this page it just says energy. But what do we measure energy in? We're going to measure it in kilojoules. So we have hydrochloric or hydroiodic acid plus energy produces hydrogen gas plus iodine gas. But also, what's it given us over here? It's given us the delta H. It's positive. Okay, so energy is going into the reaction. delta H is positive, so we know that is an endothermic reaction. Just write endo or exo. But look at number 8. We've got this peroxide produces water plus oxygen plus energy. Again, energy is on the product side, and again, what do we measure that in? Kilojoules. Okay, so we've got energy coming out of the system, and I've got a negative delta H, so that is an exothermic reaction. Okay, so either it's going to say energy, or it's going to have a value for energy measured in kilojoules. Okay, so we could have a value for energy, just like the ones on the next page, where you're going to see an actual value for the amount of energy produced or the amount of energy going into the system. All right, so you should be able to answer 9, 10, and 11 by yourself. Number 12, okay, under law of conservation of energy slide, let's look. It's going to tell you what happens to this. So go back and look at your notes for that one. Here you're going to determine if these represent endo or exothermic reactions. And again, the system is going to be the candle. Is heat coming off of the system, exiting the system, or is it going into the system? Okay, so heat is exiting the candle, so that means it is exo. Or is heat entering the system? That's how you know the difference between the two. Okay, so you can fill those out by yourself. When you get to the next page, it's repeating a lot of the things you just learned, but we're also going to include graphs here. And where would I find those graphs? I'm going to find those back on this page here. And we see endothermic. You see where heat's absorbed. That's why you get positive delta H. And here in the exothermic, heat's being released, so we get negative delta H. Okay, see if you can do those on your own. Ask me if you have any questions.